To begin today, we have a warm-up, and our warm-up says, what is the area and perimeter of the triangle if you enlarge it by a scale factor of 2? So, before we can find area and perimeter of a new triangle, we first have to change the triangle by a scale factor of 2, remember. So we multiply everything by 2, just like last unit. So our new and improved triangle has a side of 20 centimeters, 16 centimeters, and 12 centimeters. So to find area, remember the area of a right triangle is 1/2 base times the height. So we're going to have 1/2 of 12 times 16. And when we multiply it all out, we get an area of 96 centimeters squared. We then have to find the perimeter. In perimeter, we just add up the sides. So we have 20 plus 16 plus 12, which is 36 plus 12, which gives us a grand total of 48 centimeters. So we found perimeter, we found area, and we found the new enlarged triangle. And today we're going to be learning about more types of angles. So we've already talked about supplementary and complementary, and now we're going to learn a few more today. So to start today, we have vertical angles, which are also opposite angles. So go ahead and pause the video and go to that link that I have provided in the video, and go see if you can figure out what vertical angles are. Now that you've looked at what vertical angles are on the link, notice that vertical angles are also called opposite angles, and that's because they're the angles opposite each other, but they're always equal. So vertical angles are opposite each other when straight lines cross, and they're always equal. And that is the key to remember, always, always, always equal. And then when we're looking about how they relate to complementary and supplementary angles, notice this line right here. It forms a supplementary angle. So a vertical angle is part of supplementary angles. And that's an important connection to make because it's going to come in helpful when you're solving for these missing angles in our future. And now that we know a little about complementary and supplementary angles, let's see if we can figure out what they are. So in this first image, we have two lines that intersect. And we're given that this angle right here is 65 degrees. And we need to find the other angle that is 65 degrees. Well, we know using vertical angles or opposite angles, right here has to be 65 degrees. And that's its opposite angle. Now to find the measure of angle x, we need to look at these lines rather than intersecting lines. Now, this angle is supplementary with this one. And so we can say 65 plus our x is 180. And when we solve, we get x equals 115 degrees. So we can confidently say this is 115 degrees. And due to complementary vertical angles, we know this side is also 115 degrees. Our second one asks us what other angle is 35 degrees. We have our two intersecting lines, which are mandatory. So if this one's 35, over here must also be 35 degrees due to vertical angles. Then we're given that the other side is 145, Once again, due to vertical angles, x must be 145 degrees. So on our other side, it's easily 145 degrees. And note, when we look at these two in relation to this line, these are supplementary angles. And when we add them together, we get 180 degrees. The next slide asks you to solve for m, then find all angle measurements. But let's first solve for m. We have our two intersecting lines, which means that vertical angles are equal. So we can say 2m plus 10 from this side equals 5m minus 80 from over here, because those angles are equal. And now we need to solve for what m is. So subtract 2m and add 80. We have 90 equals 3m. When we divide by 3, m equals 30. And using that, we can find our four angle measurements. So as m is 30, right here, 2 times m, or 30, plus 10. 60 plus 10, we can say this one is 70 degrees. So angle CEA is 70 degrees. Due to vertical angles, we know this side is also 70. So BED has to be 70 degrees. And now we need to use our rules of supplementary angles. Here's our line. So we're going to take 70 degrees plus our unknown angle CEB. It's going to equal 180. We can say angle CEB equals 110 degrees. And if that one's 110 degrees, its vertical angle must also be 110 degrees. And so that is the rest of our answer. The next angles that we're going to talk about are interior and exterior. Now if I provide you with this picture, using what we already know about the words interior and exterior, which angles are interior? Well, right here, notice, we have a full enclosed triangle. So the things inside triangle must be interior. And that's what they are. So this angle right here and this angle are both interior. So we can say angle CBA and angle BAC are both interior. So if those are inside because they're interior, exterior are outside the triangle. And that's this angle right there. And that angle is angle BCD. And that lies outside our enclosed triangle. So that's our exterior angle. And then we know that angles BAC, ABC, and ACB are the three angles of our triangle, so they add to 180 degrees. Essential to know and remember. And now if we erase what we have, right there, it asks us which angles are supplementary angles. So they form a straight line, or 180 degrees. And right here, we see that. We have the exterior angle, angle BCD. We also have this interior angle right here, which is angle BCA. And if we would add them together, we would have an angle that adds to 180 degrees because they're supplementary. The next slide asks us to find the measurements of angle 1 and angle 2. And we're going to use that information from our first slide that we just talked about. Notice right here we have a triangle, and the triangle adds to 180 degrees. And so we can say that 30 plus 42 plus our angle 1 is 180 degrees. 72 plus angle 1 equals 180 minus 72. Angle 1 equals 108 degrees. And now for angle 2, it's out here. Remember we talked about the supplementary angles. So we can say angle 1 and angle 2 sum or add to 180 degrees. Angle 1 is 108 and angle 2 is unknown, but they equal 180. We subtract 108 from both sides and we get angle 2 equals 72 degrees. Oops, this is 108 up here. And then we have our two solutions. Our final problem is off of 10 marks. And make sure you do your 10 marks. It's very important you understand this. So we need to find all angle measurements. And we're given 135 degrees and that's 60 degrees. So we need to find everything. And where I'm going to start is I'm going to start by finding what seems easy. Right here, we have two supplementary angles. So I know that 135 plus angle AFB is 180. When I add them together and solve, I get angle AFB equals 45 degrees. And now I'm going to easily see right here are my two straight lines that cross. So right over here is a vertical angle. So that has to be 45 degrees. So angle EFD is 45 degrees. And it's because of vertical angles. Now finally, we have this angle right here, angle CFD. There's a lot of ways to solve this, but I'm going to look at it a different way. I'm going to look at it as a supplementary angle along this line, which encompasses this one, this angle, and the angle we're finding. And we know together they equal 180. Now we just put in what we know. The first one's 45 degrees, plus the second one, which is 60 degrees, plus our unknown angle, and they equal 180. So we have 105 plus x equals 180. When we solve, we get x equals 75 degrees. So right here we have a 75 degree angle. So angle CFD equals 75 degrees because of supplementary angles. Not the only way to do it, but that's what I prefer. So, now you have some assignments to do, and come to class tomorrow with questions. Good luck tonight.